All right, and time for more fun than any student should be allowed to have. Exactly. I realize that you don't think that you deserve this as much, but you know, I would be remiss in providing you this wonderful information. So, here we go. We will. Two functions are said to be identically equal if, you know, f of x is equal to g of x. So two different functions, if they have the same outcome, they're called equal, right? So what we've got here, information that you should make sure that you have available to you for yourself, are some nice little identities. Tangent, cotangent, you know, reciprocal identities, which we've already talked about, Pythagorean identities, which we have somewhat dealt with. But now we also have these even and odd identities. So for example, the sine of negative theta is equal to the negative sine of theta. We're just identifying the things that are going to be equal. So when you're given a trigonometric, you know, expression and you need to simplify it, we go through and apply those things. That's all that it really requires. So let's go through and take a look at a couple of these. So I want to simplify this down. I've got cotangent of theta over cosecant of theta. Well, the question is, what are they equal to? So if I go back here and take a look at what my identities provide me, let's see, cotangent is sine over cosine, or cosine over sine. So I can rewrite this as cosine theta over sine theta. What is cosecant? Cosecant is 1 over sine theta. Well, multiply by the reciprocal because we can't divide by a fraction, so we get this. Those cancel out, and this simply equals cosine. That's really all that we're doing with it, is just rewriting it and simplifying. Not that big of a deal. So, establishing identities. It is possible to go through and create new identities for things that you need to use. For example, if you wanted to create another identity for secant, you know, cosecant theta times tangent theta is equal to secant theta. Is this true? Well, what's cosecant? Cosecant is 1 over sine theta. What's tangent? Sine theta. 1 over cosine is the same as cosecant, or secant, I should say. So really all that they're doing is just plugging them in, using the identities to rewrite things into a new form. Establishing another identity. Here I've got negatives that are in there. Well, the negatives are the same as what? So if we go back up here, take a look at here. If I have the sign of negative, it's the same as the negative sign of. So I can do a substitution. Okay, plug it in, away it goes. But it's really just simply taking the information that you have, putting it back in, and simplifying. Nothing more than that. More or less just simply mental gymnastics. So, these are some guidelines for it. Always preferable to start with the side containing the more complex expressions. Whenever you're working on this, work with that. Rewrite sums or differences of quotients as a single quotient. Okay. You want to try and get yourself something on top divided by something on the bottom. You don't want to have any additions or subtractions going on. Okay. And like I said, next thing, sometimes rewriting one side in terms of sine and cosine functions only help, because then you can go and simplify down. Mind you, always keep your goal in mind. As you manipulate one side of the expression, you must keep in mind the form of the expression on the other side. This is very much mental gymnastics. A lot of writing is required, but the reality is it's really no more than algebraic manipulation, given specific things to work with. So I'm going to turn you guys loose on this stuff.